Stop me when you have questions. So this one we would multiply times 5. Yes, good. Then we would end up with 3y minus 10 equals 1. And then we would add 10 to both sides, and we would end up with 3y equals 11. And then we end up with y equals 3 2/3. Questions on that one? Yes, no, maybe? Okay. I need a keyboard, a separate keyboard. Make my life easier. That's okay though. And at least I have the tools, huh? Hello. What you doing? Okay. So this one we multiply. Hello. Oh, I know why. I need a keyboard. Need a keyboard. It's okay. This one we would multiply times 2. And we would end up with -1 minus 2x equals -4. And then when we add 1 to both sides, we would end up with -2x equals, sorry, my handwriting is going to be even worse than normal because of the way I'm doing this. Let me get my little stool at least help a little. Not a lot, but a little. Okay. Okay. Yeah. Where were we? Where we're at equals -3, and we end up with x equals +1 1/2. And you have a question. Okay. Okay. Did you just did it like without clearing the fractions? It's probably fine.
I got x equals 3 because I forgot to put the -2.
Why'd you forget that? Yeah, that's an easy, I was talking about that the other day with y'all, and I've actually said that to other people as well. That's an easy mistake to make when you're doing these. And again, the reason why we're doing these this way is now you can, because we know how to work with fractions, right? Y'all are great at that, especially if they've already got a common denominator. We've practiced the heck out of that. So you could leave the fractions in and do it that way. The reason why we're doing it this way is because it's kind of prepping us from some things later. That where it's gonna be way easier to clear the fractions early, and especially when we start getting x's and other variables down in the denominator and all kinds of crazy stuff later. So that's why we're doing it this method. So.
But when you have a -x,
Uh-huh.
you just put whatever is on the outside of the brackets inside the negative. And that's how you do it.
Well, okay, I think I know what we're talking about. Let me clear my selection there. So remember, I think this is going to answer your question. If not, then let me know. But remember that if there's not a letter, or excuse me, a number here, then there's a, oops, I need the right tool, huh? There's a hidden one, there's a hidden 1 here. So it's 2 times -1, which is -2. That's why that ends up being that way. There's always a 1. If there's not another number, then it's always a 1. That's right. That's 100% right. Mm-hmm. Absolutely.
Do you always multiply the variable?
You always multiply every single term. So yes.
And the variable always turns into 1.
It always does what now?
Turns into a 1.
Well, if there's not another number there. So like on number 4 in a minute, it's got 3 halves there, right? And so it's going to have, you're multiplying times the 3 instead of a 1. So it kind of depends. All right. Woo. crooked. Okay, so then the next one we would have multiplied times, sorry, trying to go too fast. Multiplied times 5, right? And so then when we did that, we would end up with 5a minus 7 equals 10, right? And then we would have added 7 to both sides and ended up with 5a equals 17. And then when we divided the 5 off, we would have ended up with a equals 3 2/5. Questions on that problem? Well, don't forget to bring that. Those are those kind of mistakes. We're gonna have to just continue, and that's why we're continuing to practice. Those kind of things are easy to do. We just gotta get it in our head to not to do those, right? To not to. Let's grab this one and take this and pull it up here and close that away and do that. Blammo. Okay. So this one, there's two different ways to do it. So this one, let's actually kind of talk through, because there's two different ways to think about this problem. So what's one way we could have solved this?
Do 2.
On everything?
No.
No.
Do 6 times 2 and 6 times 3.
6 times 2 and 6 times 3, is that what you're saying? Okay. So, like right here, like here we do times on the 3 over 2. Okay, I'm confused now, I think. Oh, okay, I see. Okay, I think I'm following. So on this one, we multiply times 6 over 6. Is that what you're trying to say? Okay, gotcha. Now I'm following you. Yes, that is one way to solve this one. Absolutely. Now this one we don't have to change, right? This one's already over 12, right? So that's totally a fine way to do this one. So we've got, if we do it this way, we end up with 6/12 minus 18/12. P equals, and we're still at 7 because we haven't done anything else. So then, that's a 7, I promise. I don't know what happened with that. Okay, so then we will multiply everything times 12, right, if we do it this way. Anybody do it any other ways before I continue on, just out of curiosity?
I did brackets.
Uh-huh.
And multiply it by 2.
Okay, well, we can't quite do that, because if we do it by times 2, it's not going to get rid of the 12. You could have done brackets and we haven't done any problems like this yet. We will soonish. We could have put brackets at the beginning and put a 12 outside, but we haven't really learned how to do that. But you couldn't do it with the smaller one. We'd have to get a so with what y'all know, there's really only two. There's more than this, but with what y'all know, there's really only two ways to solve this. One is like what we're doing. You get a common denominator first, right? And the number 2 way would have been, and if you noticed that this fraction reduces, you can divide the top and bottom there by 6, and you'd get 1/2. And then you could multiply everything times 2. So with what y'all know right now, those are really the only 2 ways we could have solved it. Does that make sense? So if we're continuing walking down this way, we end up with 6 minus 18p equals, what is that, 84? Is that right? And then we would have subtracted 6 and ended up with negative 18p. I know normally we would, and we'll go back to, but just looking at the homework, normally we'll write down the intermediate steps. And if we need to on these, we will. Equals 78. And then we would divide it by 18 and ended up with, I don't even know. Let's see. I'll have to scratch paper that one since this is the class we're in. So those will reduce, I'm sure, but we'll do it this way anyway. So 18 goes into 78 how many times? What do we want to try?
4.
Sure, sounds great. 4. 8 times 4 is 32. 4 times 1 is 8. Plus 3 is 11. Too much? So what do we want to try instead? 2. It's going to be 36, but we'll work it out anyway. 8 times 2 is 16. 2 times 1 is 2, plus 1 is 3. 36, that's probably too small. So she's just right. If we do 8 at times 3, maybe. I don't know what that accent was, but you know, whatever. 8 times 3 equals what? 24 hours in a day. 3 times 1 is 3, plus 2 is 54. So it looks like that's the best we can do. So 3 right here, 54, unless I've made a mistake. Y'all are my eyes watching for my mistakes, right? Yeah, sure. 7, what?
18 times 4, you do 8 times 4 is 32. Carry the 3, and then do 1 times 4, and then 4 plus 3 is 7.
72. How dare he? Because it's a good strategy, that's why. Because I learned things in teacher school. Yeah, strategy. I didn't learn any English in teacher school, only math and how to teach it. 78 minus 72 is 6, right? Oh, there should be a 4 here. What has happened? So 4 and 6/18. I bet we could reduce 6/18. What do you want to bet? What can we reduce those by? No. 6 and 3. We can go big or go home and reduce it by 6. What's 6 divided by 6? 1. And what is 18 divided by 6?
3.
It is 3. 1/3. Yes, ma'am.
I did it way differently than that, but I still got
Somehow still got the right answer?
Yeah, and I got that same answer too.
Then you may have, in your methods, still ended up working it out right. That's possible. Because you could have multiplied times 2 and still got it out right. You just wouldn't have cleared the fractions. So, good job. All right. Bring me back this stuff. Grab a marquee. Blammo. Cut it. Oh. Cut it. Pop it over there. Stick it up somewhere useful. Oh, it came back down here. Where'd it go?
Isn't this the same setup you
Well, yeah, but I use a better computer there. But yes, it is the same program I use. I have a better setup at my casa, but now that I have RAM, I can ditch new whiteboard and use this program here. Because new whiteboard is garbage.
Is that like your favorite talking point? Is that your favorite
No.
conversations to have, that new whiteboard sucks?
No, it's not my favorite conversation to have. No, it's not my least favorite either. I think that's no, not true.
It's happy, you bring it up a lot.
Well, it is garbage. I wouldn't talk about, it's one of those things, like I don't care if the program is bad. I just don't like that they forced me to have it. Why couldn't they have left the old one that worked and wasn't tied to the internet? Okay, so we would multiply 9 on everything, and we would have ended up with B plus, that'd be 90 plus, what's 8 times 9? A whole heap, 72. Haha, 72 plus 90, so 162. Does that sound right?
Yes, it does.
This is number 5. Minus 45. And then when we subtract, Yes.
When you're multiplying them,
Uh-huh.
I got 1 9 when b equals -23.
What'd you multiply by?
9.
Well, when we do 1/9 times 9, those cancel, right? And so we just have b. And then we can double check the 18 times 9 since I did that in my head.
I got 1.
Okay, so we at least have 1 second, but we'll triple sanity check.
Just to verify.
9 times 8 is 72. 9 times 1 is 9, plus 7 is 16, right? So I don't know, girl, but that's what would happen there.
Well, Dad was helping me with this problem, and he said that if I did it a certain way, I forgot how to do it.
If you subtracted the 18 and ended up with, and then multiply both sides by 9, is that what he told you to do? I bet almost anything, which is a great way to solve this problem, by the way. He was not wrong, and in fact, most teachers at this level would teach you that way only. I just am teaching you this way because I'm prepping you for other things. And if you want to solve it that way, that's totally fine too. But if you learn this too, then you get more tools in your tool belt. Okay, so when we subtract by 162, we end up with b equals negative 207. Any other questions on this problem? What? You forgot to write the negative. And we got one more, right? Don't forget to write the negative. Oh, that one's easy. Let's just leave it shoved over here. I forgot I gave y'all one that was easy. Let's just leave it right here, shall we? Deselect it. So when we add 8 to both sides, we end up with negative z equals 11. 11. And then when we divide by -1, we end up with z equals negative 11. Blammo. Any questions on those homework problems, boys and girls?
I think z equals 12.
Because you added wrong on accident? Yeah. Sounds reasonable to me. Oh, I forgot to. Well, that's okay. I can do it now. Control Shift S. What is today? The 11th? 04 11 dash middle school dash two-step uncommons, which is what we're going to start practicing today. But we are probably going to barely scratch the surface. We may not even get to 2 steps because we're going to re-practice finding least common multiple. We're going to practice, and we're going to practice the heck out of that because that will help us as we continue along down the line. Okay. So, let me flip this around so I can slightly improve my handwriting. Slightly.
Well, we're happy for slight improvement.
Yay.
Find out when it comes to math, so we can slightly improve every day, or every math day.
Okay. We have done this before, and you have probably, not necessarily, but probably done it in another class, in other classes as well. But we're going to practice finding the least common multiple. Okay. And then we're going to transition that into least common denominator, because it's the same thing. Okay. LCM. Right? So we're going to look at two numbers. We're going to start with 2, and then we're going to go move on to 3 as well. We're going to find the least common multiple between two numbers. Okay? So let's pick the number 4 and the number 6. Okay? So we want to find the LCM between the two of those. Right? So we're going to do it by just kind of walking them out. The better you have, I've said this before and I'll say it again. If your parents happen to overhear this video, then more power to them. The better you have your multiplication facts, the easier these problems will be. If you have them memorized really well, then these problems will be cake. Because I can already tell you without doing all the work we're about to do that the least common multiple between these is 12. I can tell you that without even thinking hard because I have my multiplication tables memorized. Okay? But let's walk through how to do it if we need to skip count. So what are the multiples of 4? What's 4 times 2? 8. And then 12. And then and then
I feel like we're
yes, we are.
28.
24. That's probably 5 is probably enough to be getting on with. Okay. So multiples of 6. We've already found one, but 6, 18, 24, etc. Right? And so what we're looking for is the first ones to match, right? So right here and right here. So what's the least common multiple between 4 and 6, boys and girls? What's the answer to this problem? 12. Let's do another one.
But couldn't you just do 4 plus 6?
4 plus 6? No, you couldn't, because they're multiples, not addiples.
But that's an addition.
That's an and sign.
Because it has the little dash in it.
Okay. So, least common multiple between, let's pick, how about 7 and how about 12? Sure, why not? Let's start with the bigger number. It's a good idea to start with the bigger number because we may have to go less far with the other number. We didn't do that before, but we're going to learn a new strategy. So what's the multiples of 12? 12, and then the next one. 24, and then 36, and then 48, and then... Well, we've gotten 12 times 4, so 12 times 5, so we're just adding 12, yeah? 60. And then 72. And then 84. So it's worth noting, and this is not really what we're learning today, but this would be times 2, 3, 4, 5, 6, 7. You never have to go further than the other number. Never, ever. Because if you go that far, then you know that's going to be where you're at, right? So let's think about multiples of 7. 14, 21, 28, 35, 42, 56, 63, And then we haven't found anything matched yet. We got to keep going. What? 63 times 10 would be what? 63 times 10. That'd be 630. But 7 times 10 is what? 70. And then 84. So what's the least common multiple between 7 and 12? 84. Let's do another. Let's pick.
I haven't had this much fun writing down a bunch of numbers since we did number chains.
5.
Are we having this for homework?
This will be part of your homework, or all of your homework. Haven't decided yet. We shall see. 1 and 15. Again, let's start with the bigger number. Where's the multiples of 15? What's 15 times 2?
30.
15 times 3? 45. 15 times 4? It'd be 2 30s. 60. That's probably plenty to be getting on with. All of those are multiples of 5, but you know, there it is. So what are multiples of 5?
10 and then 15.
10 and then, oh, we found it. So what's the least common multiple of 5 and 15? 15.
Lo and behold.
But there was,
They're all multiples of 5. We're looking for the least one. The leastest one.
Lo and behold.
Okay, so y'all are getting the hang of this, so let's kick it up a notch and a half.
A notch and a half. Why?
Maybe just one notch. What's the least common number between least common multiple between 2, 3, and 6? So let's start with the biggest one. Let's go to about 3 and see what happens. 12, 18, 24. Let's jump back over here. What are multiples of 3? 6. Oh, look, we found one that matches. Let's see if it matches over on the other one. What are the multiples of 2?
4, 6, crazy.
Oh, look, it matches. So what's the least common multiple between 2, 3, and 6? 6.
Wait, why is there 2 4?
Because I don't know.
Because we're all slowly going insane.
Yeah, I don't know what you're talking about. It said 6 the whole time. Oh my gosh.
Eli's gone crazy.
OMG. Okay, let's do another.
My ears have been confirmed.
Let's do another one. How about
1, 0, and 2.
no? The problem with that is there's not one because of 0. That's a tricksy one. 0 ruins everything. 0 ruins everything. Because you cannot multiply anything times 0 and end up with 1. Can't happen. Do what?
what if it was a number and then
Oh, a 0 in the unit. Yeah, you could do that. Sure, absolutely. How about we do... Too bad Asher's not here, but he'll watch the video. This one's for you, Asher. 72. And let's do 18 and 24. Oh no, those are all big. Okay, so since they're that big, let's put a pin in the big one, in the 72. And we'll kind of cross our fingers and hope that 72 is a multiple of both of the other two. It may not be, but let's hope. See what happens. 'Cause if not, we may have to go really big. So let's do it. Let's do multiples of 18. So y'all scratch paper if and when you need to. What's 18 times 2? Scratch paper, please. Scratch paper, scratch paper, scratch paper.
36.
36. That's not 72. 18 times 3. 54. 18 times 4. 72. Okay, so that works. Let's see if it works for the other one. 24 times 2.
48.
24 times 3. 72. So what's the least common multiple between those three?
72.
72.
Lo and behold.
How we doing? Pretty good? Okay. Let's put this concept. Anybody have any questions on this? Anybody having a hard time with this? Anybody confused? Okay. Let's make us a new layer here. Hide this one. And then let's add this topic to our last topic. And let's answer a question that has been asked at least 3 times, which is great. I'm glad your curious minds are working. It's wonderful. It's how we learn. Okay. So, let's do a problem like this one. We're going to call this example 1.
How creative and original.
I know. Creative and original. 1/2 minus.
Wait, could you ever do fractions with least common multiple?
That's what we're doing. Well, we're looking at least common denominator, so we're kind of putting that together. 2/3 P equals 6. No, LOL JK. I got too excited. What I meant to say was 5/6. Okay. Now, we're going to do this the same way. Okay? We're going to do this the same way we're doing the other one. We're going to use the brackets, and we're going to multiply that out that way. And generally speaking, if you're struggling with one and you know another way to do it and you want to do it that way, go for it. It's fine. If you're struggling, do it however it works for you. If your parents are like, I don't know how to do this, but you can do this, that's fine. Thumbs up. Thumbs up to you, thumbs up to your parents. It's great. No problem. If your parents are like, why is he teaching you this? It's so much easier to do it this way. I'm teaching you it because of the future, so you can tell them that. It's not because my teacher is a complete and utter idiot.
Because of the future.
It's because the future. But yeah, all the things are good. So we're going to figure out what the least common denominator is. So what's the least common multiple between 2, 3, and 6? Y'all figure that out for me real quick.
We already did this. It's 6.
We did.
We already did this.
It's 6, right? So this is these are the steps that we're going to do. Once we know the least common denominator, we're going to put a big bracket, and we're going to put that number on the outside. How we doing? Any confusion?
But couldn't you have just done it this way with
The other ones?
on homework number 4?
Yes. Yes, you could. Yes, you could. But you didn't know that yet. But yes. Okay. So then you're going to do it the same way we've done everything else. You're going to multiply that number times everything. Let's walk through that step by step. So 1/2 times 6 minus 2/3 times 6 p, right? Remember to put the p in there, equals 5/6 times 6. I really hate that word, sixths. It's a terrible word.
I think you also said, like, a while ago, you said you didn't like the word, like, divisibles, or, I don't know.
Divisible? Yeah, I don't remember. I do kind of vaguely remember that conversation, but I don't remember what I was fussing about.
Something like, because it had too many I's or something.
Oh, yeah, I didn't like spelling it. That's probably the truth. Okay, so these would all be over 1, right? Because if there's no denominator, we can put it over 1, right? Any confusion so far? Making sense? Any questions right now? How we doing?
Wouldn't an easier way is to just write down all the numerators?
It's not going to work that way this time. Not quite. Because this time, when we pre-reduce, what is this first one going to pre-reduce by? What goes in the 6 and 2? 2 does, right? What's 6 divided by 2? What's 2 divided by 2? 1. So this one turns out 3 times 1, and then, of course, 1 times 1. The denominator is always going to disappear. Always. It's always going to end up being 1 times 1. If it doesn't end up being 1 times 1, you did something wrong. So all that's left here is 3. Minus. Now this one, what's this one going to reduce by? 3. What's 6 divided by 3?
But why do you write a 3 minus?
The 3 was from this. The minus is bringing that minus from here.
But you said you always bring the numerators.
No, I did not say that. I said if we only have one, and this is exactly how I answered that question. If there's only one kind of denominator, then it's just going to be the numerators. This is when the denominators don't match. That's what's new about today. Which is why we're going ultra slow, which is great. What is this reduced by? 3. So 6 divided by 3 is? No, 6 divided by 3 is 2. And then 3 divided by 3 is? I am pre-reducing. I expect you to do the same. What's 3 divided by 3? 1.
Said it like 3 times.
That may be true. I didn't actually hear you. Okay.
You know that you're doing it by 3.
Because 3 goes into 3 and 6. So then negative 2 times 2 is negative 4p, right? What are we going to reduce by on this very last one? 6. 6 divided by 6 is what? 1. This one will be the numerator, right? Because we reduced it all the way. Because 5 times 1 is 5. Now we have a super easy, barely an inconvenience problem that we could solve without thinking hard about it, right?
It's like I'm going to break into your house problem.
What?
Minorly inconvenience.
What should we do now to solve this guy? This one we know how to do in our sleep. What should we do now? There aren't any. We killed all the fractions. This is all we got left right here. 3 minus 4p equals 5. What's my first step to solve that? No, we don't want that. 4 isn't added. It's right next to. Right next to is multiplication. But we want to get rid of the addition subtraction one first. So we want to get rid of that guy first.
Minus 3.
Got to minus the 3. first. Minus 3, if we do it to that side of the equals, we got to do it to that side of the equals. We bring down minus 4p equals, and then 5 minus 3 is 2. Are you good? Okay. In this problem, at this point, what are we going to do?
Divide 4.
Negative 4, right? So we're left with a p equals, and then 2 divided by negative 4, what's that going to reduce to? Negative 2 over 4, right? But I see what you're saying. What are we going to divide both by? 2. So what's left on the top?
1/2.
That's right. How we doing? We making sense? Let's do another one like that.
Is this shall
We might do 1 or 2 of these.
shall it be named example 2?
It shall be named example 2. Astonishing. Example 2 is going to be 6/7 x minus 3/14 You know what my real problem with 3s is I still can't figure out how I like to draw them, because even when I actually slow down and think about it, I still never like it. I just don't like 3s, I guess.
Well, I'm sure that it is.
Equals, what?
I'm sure the 3s feel the same way.
Equals
I'm sure the 3s
5/28. So I need the least common multiple between all the denominators. So I need the least common denominator. Y'all work that out for me. You can use your skip countings, or you can just look at it.
I think it's just 20.
I think it's just 28.
No, that's a lie. Wait, no.
How do you find the least common denominator?
So we list them, right? And list the multiples of each and find the smallest one that works for each, just like what we were doing on the other bits. So just like this stuff. Just like that.
28.
Yeah, it's 28.
I didn't say you were wrong. You just second guessed yourself, so I was waiting for you to be sure. It is 28.
I mean, it should really well enough by now.
I know you really well.
That is my second nature.
Biggest number?
No, not always. It just worked out that way on these last two.
Second guessing myself is second nature.
Okay. So we end up with 28 times each thing. Right? So 6/7 x times 28 minus 28 times 3/14 equals 28 times 5/28. Eventually, believe it or not, you'll be able to do this step in your head eventually.
Yeah, I believe it.
Just not today. Okay. So we're going to pre-reduce on all of these. What are we going to reduce this guy by? What goes into 28 and 7? 7 does. What's 28 divided by 7? 7 divided by 7? What are we going to reduce these guys by?
28 and 14.
Yeah, 28 and 14. What are we going to reduce those by? 14. What's 28 divided by 14?
2.
And then 14 divided by 14? And then what are we going to reduce these by? 28. So 1 and 1, right? So 4 times 6 is what?
24.
So we've got 24x minus, and then what's negative 2 times 3? Negative 6. So negative 6 equals, and this one's just going to be 5, right? Now we have a thing that we know how to solve without even thinking hard, right? What should we do now to solve this guy?
Children love not thinking hard. So, you know.
Add 6.
Add 6. So we've got 24x equals 5 plus 6 is 11. And then what should we do now? By 24. Okay, let's write some homework. Y'all's favorite. We're going to do 2 types of homework this time.
But wouldn't you divide it because that line?
They don't reduce. Is that what you're talking about?
So if they don't reduce, you don't divide it.
Well, that is division. I mean, yeah, so there's nothing, if this top number is smaller than the denominator, for one thing, then we don't divide it, because the only reason we would divide it is if we were trying to convert a improper fraction to a mixed number. Okay, let's write down some homeworks. Homework number 1. For these first few, we're going to find the least common multiple. Okay. Number 1, find the least common multiple between 8, 3, and 2. For number 2, we're going to find the least common multiple between 5 6, and 15. Not as hard as it looks. It's actually a pretty easy one, but I'll let you discover that for yourself. Number 3 is going to be 2, 3, 4, and 6. Number 4.
12.
What?
12.
Yeah. That's the answer. Good job. So easy. Number 4 is going to be 6, 7, and 8. Out of all those problems, easily the hardest is number 6. Excuse me, is number 4.
Yeah, thank you.
But none of them are that bad. Now, the instructions for the second group of problems is going to be solve.
Can any of those not have a least common multiple?
They will always, there is always a possibility for least common multiple. It might be really big, but there will always be one. That's a great question, actually. All right. So, number 5. Because, and I'll give you a hint on that, if nothing else, if you can't get to one any other way, you can always multiply all 3 of them together and get a multiple. It may not be the least, and remember we're looking for the least. But if no other method will suffice, that will ultimately work. Number 5, we're going to solve 6/7 y plus 2/3 equals, how hard do I want to make it? 1/2. It's harder than it looks, but you got this. And number 6, we're only going to do 6. Number 6 will be a little easier, probably. Negative 2/3 minus 1/5 a equals negative 1/15. That one's not so bad. You may scroll up, or you can copy all the other ones. I'll put this on as the last thing on the screen on the video anyway. Any questions before I say goodbye?
You already said it, so.
Technically, yes. But my inflection was not right for goodbye.
But why do you put a question mark next to the least common multiple?
Because it is a question. This one is a declarative. Solve. That one is, what is the least common multiple? Question mark. Goodbye, kids. Talk to your mother.
Speaking of, my mom said yeah.
Your mom said, yeah. Y'all are interested.